Hello, c'est Jean-Marc from MilliBox, and today we are going to talk about MBX32CTR. MBX32CTR is our latest newcomer in our portfolio for 2024. It's a compact antenna test range for the first time. So that's a big departure from what we've been doing in traditional far field until now. And I'm going to tell you all about it. MBX32CTR is an extension of the work we've done with Aeravent on the MBX32E. That's the object of another video that you can check on our channel. On MBX32E, we cooperated with Aeravent with their frequency extenders that allowed us to go to 330 gigahertz. Today, with MBX32CTR, we're adding the reflector capability thanks to Aeravent's precision milling fabrication expertise. There are typically two methods to measure antenna and RF system over the air. One method is called near-field scanning, and we're not going to talk about that because we don't do anything about this. Our technique has always been related to far field measurement. So far field over the air measurement is driven by a rule which is 2D square over lambda, and that's D means the size of your antenna and lambda being the wavelength of your antenna, the frequency. That dictates how far you should put your probe away from your DUT. As we're going into mmWave and Sub-THz, the frequencies get very high, so the far field has a tendency to get much smaller. And that's why that's all the story behind MilliBox compact chambers in far field that can fit on a lab bench. As the phase arrays, as the antenna gets bigger aperture, there's a tendency to make the distance, the measurement distance, the far field distance farther away. So at MilliBox, the approach to the far field distance is that you have a number of cubes and you decide based on your far field requirement, based on your DUT characteristics, you're going to choose whether you want an MBX2, like with 2 cubes, and three cubes, and 4 with 4 cubes, in order to get to that far field distance required. So there's another way that allows us to eliminate the far field requirement, and that's CATR. Basically, it's a compact antenna test range where, because we use parabolic reflector and a probe at the focus point of that parabola, this abstracts the far field requirement. And that's very useful when, even though your frequency is very high, your antenna array gets bigger and bigger. That's something we see a lot in automotive radar, for example, and for SATCOM, where even with the largest MilliBox, we cannot make it long enough to reach the far field distance of some of our customers. Hence the need for MBX32CTR. So basically, instead of doing 2 points, we have the DUT on a positioner, and then we have a probe fixed on the horn post. That has been the way we've been doing things we started. We eliminate the need for the post. We put a reflector, a parabolic reflector, and then we have the parabola as a focus point. At precise focus point, we're going to put our probe, and that reflection abstracts the requirement for far field measurement distance. So let's take a peek inside. Here, first we recognize Gimbal 4 300E. That's the same Gimbal 4 positioner we used for MBX32E. And that's the type of positioner that allows us to go from 50 gigahertz all the way to 330 gigahertz. So in the context of MBX32CTR, we have a choice whether we want to go coax and have a normal Gimbal 4 300 platform, like just a flat platform or we want the models 300E, which add the mount for the irrelevant frequency extenders, and that pushes all the way to 330 gigahertz. So on this side, that's where we see our parabolic reflector. Our parabolic reflector is the square of 30 centimeter. So as a rule of thumb, 30 centimeter parabolic reflector is going to give us a quiet zone of 15 centimeter. 15 centimeter is the maximum size of the DUT will be mounting with this type of system. So one important characteristic of our reflector, it's a rolled edge. You know, there are different methods to avoid some artifacts that we can see with a parabolic reflector like this. One is to have some kind of spikes that are on the side of the reflector. One is to have a rolled edge. So we have a rolled edge in our case. So another, I would say the third component after we saw the 3D positioner, the parabolic reflector. Now we're looking at the probe system for a compact antenna test range. Here you can distinguish maybe the probe tip. It's a D-band tip, so it's fairly small. And then when we open the cover, we can see how it sits inside. So this is the probe system when used with extenders, like it's our case today, because we're using D-band extenders to 170 gigahertz. And here we have, you see the extension for the probe, and you see the knobs and adjustment that we can do to align precisely the tip of the probe to a specific focus point with respect to the parabolic reflector. So we make those adjustments manually with the help of lasers, and that's how we reach the precise point for the focus of our probe, and we can get started testing. So that's what we're going to do. We're going to do a run and see how it goes with the software. So now here we are. We're seeing our controller and our VNA. We are going to do a 3D plot. We're going to do -50 to 50 degree in both. Okay, and we're going to plot at 140 gigahertz. And we started slicing. So now our plot is completed, and then we can do 3D. We can do a rendering in 3D of our measurement. So there's no difference when we do the same. I mean, you can check some other videos that I made where we talk about D-band measurement, and we do about the same measurement, but on a direct far field, like not a CATR setup, and we get pretty much the same data as here. All right, so I think we have a good understanding of what MBX32CTR is about. So at the end of the day, you have two situations. You can add cubes to a MilliBox, to your MilliBox system to reach the far field that you need. But at a certain point, it becomes impractical. And that's when you need to think about MBX32CTR, where it's compact and it has that parabolic reflector and probe system that allow you to reach far field distance that you cannot do physically in a direct far field environment. In that case, you call us and you ask to know more about MBX32CTR and see if that would work for your application. So that's all for today. I hope that was instructive. If you have any question, don't hesitate to send me an email. Otherwise, talk to you later.